Imagine waking up to the sound of rain pattering against your window. Ah, the perfect day to stay in bed, right? Well, not if you're on WASP 76b. Because on this nightmare of a planet, that soothing pitter-patter isn't water, it's molten iron raining from the sky. Now, I've always been a bit of a weather nerd. As a kid, I'd sit for hours watching storm clouds roll in, hoping to catch a glimpse of lightning. But even in my wildest dreams, I never imagined a planet where the forecast could include heavy iron showers with a chance of vaporized metal winds. You see, our universe is full of planets beyond our solar system. We call them exoplanets. And boy, are they wild. We've found planets made of diamond, worlds with oceans of lava, and even rogue planets drifting alone in the darkness of space. But in all my years of studying astronomy, I've never come across anything quite as terrifying as WASP 76b. This planet is so extreme, so utterly hostile to life as we know it, that it makes Venus look like a tropical paradise. And trust me, that's saying something. So buckle up, fellow cosmic explorers. We're about to take a journey to what might just be the most horrifying exoplanet ever discovered. A world where the clouds are made of corundum. Yeah, that's the stuff that makes rubies and sapphires. A place where the winds howl at thousands of miles per hour, carrying vaporized metals across a scorched landscape. And the kicker? This isn't science fiction. This is a real place, about 640 light years from Earth in the constellation Pisces. Ready to have your mind blown? Let's dive into the hellish world of WASP 76b. I promise you, by the end of this video, you'll never complain about a little rain again. Now let's talk about how we even found this cosmic horror show. WASP 76b was discovered back in 2013 by the Super WASP project. WASP stands for Wide Angle Search for Planets, and let me tell you, they hit the jackpot with this one. You know, it reminds me of the time I first looked through a telescope as a kid. I remember being amazed that I could see the craters on the moon. Well, the folks at Super WASP must have felt a similar thrill when they first detected WASP 76b. Except instead of moon craters, they found a planet that defies our wildest imaginations. So, where exactly is this planet? Well, if you're planning a road trip, I've got bad news for you. WASP 76b is about 640 light-years away in the constellation Pisces. To put that in perspective, if you could drive there at highway speeds, it would take you about 7 billion years. Yeah, you might want to pack a few snacks for that journey. Now let's talk size. WASP 76b is what we call a hot Jupiter. It's a gas giant, like our own Jupiter, but it's much closer to its star. In fact, WASP 76b is about 1.8 times the size of Jupiter. But here's the kicker, it's less massive. That means it's puffy, like a cosmic marshmallow. But trust me, you wouldn't want to roast this marshmallow over a campfire. Speaking of stars, let's chat about WASP 76b's host star. It's an F-type star, which means it's a bit hotter and larger than our Sun. And when I say WASP 76b is close to its star, I mean really close. This planet orbits its star in just 1.8 Earth days. To give you an idea of how bonkers that is, let me share a personal anecdote. I once tried to run a mile in under 6 minutes. I trained for weeks, and when the big day came, I gave it my all. I was gasping for breath, my legs were on fire, and I felt like my heart was going to burst out of my chest. Well, WASP 76b is basically doing that. But instead of a 6-minute mile, it's sprinting around its star every 43 hours, forever. This proximity to its star leads to one of WASP 76b's most fascinating features. It's tidally locked. That means the same side of the planet always faces the star, just like how we always see the same side of the moon from Earth. Now, you might be thinking, okay, so one side is really hot, and the other side is really cold, right? Oh, my sweet summer child. If only it were that simple. Let's start with the day side. The temperature here reaches a whopping 4,350 degrees Fahrenheit, 2,400 degrees Celsius. That's hot enough to vaporize metals. To put that in perspective, the surface of Venus, which we've always considered the poster child for hellish planets, is only about 900 degrees Fahrenheit, 480 degrees Celsius. WASP-76b makes Venus look like a walk in the park on a cool autumn day. Now, you might be thinking the night side offers some relief. Well, not really. While it's cooler, with temperatures dropping to only about 2,730 degrees Fahrenheit, 1,500 degrees Celsius, it's still hot enough to melt lead. So your options on WASP-76b are basically inferno, or slightly less inferno. But here's where things get really wild. Remember that iron rain I mentioned earlier? This is where it comes into play. On the day side, it's so hot that metals like iron vaporize. These metal vapors rise high into the atmosphere, carried by powerful winds that can reach speeds of over 10,000 miles per hour. Now, if you've ever watched a pot of water boil, you know that hot air rises. The same thing happens on WASP-76b, but instead of water vapor, it's iron vapor. This superheated metal gas rises high into the atmosphere and gets pushed over to the night side by those insane winds. On the night side, where it's cooler, and remember, cooler is a very relative term here, the iron vapor condenses. And just like water vapor condensing into rain on Earth, the iron turns into droplets and falls as a deadly metal rain. Can you imagine that weather forecast? Today's outlook: scorching hot with a 100% chance of molten iron downpours. Don't forget your umbrella, made of tungsten. You know, this reminds me of a camping trip I took once where it rained so hard my tent flooded. I thought that was bad, but at least I didn't have to worry about my sleeping bag being incinerated by falling liquid metal. But wait, there's more. The clouds on WASP-76b aren't your fluffy white water vapor clouds. Oh no, that would be far too normal for this planet. Instead, the clouds are likely made of corundum, the same mineral that forms rubies and sapphires on Earth. So in a way, it's raining gemstones. If those gemstones were hot enough to vaporize you instantly. Now you might be wondering, could anything possibly live on this nightmare world? Well, I hate to break it to you, but the chances of life as we know it existing on WASP-76b are about as good as your chances of surviving a swim in lava, which is to say, absolutely zero. But here's where it gets interesting. Studying extreme planets like WASP-76b actually helps us understand more about our own solar system and how planets form and evolve. It's like looking at the most extreme case scenario and working backwards. For example, by studying the atmospheric composition of WASP-76b, we can learn more about how gas giants form and how they're affected by their proximity to their stars. This, in turn, helps us understand the history and potential future of our own gas giants like Jupiter and Saturn. Moreover, planets like WASP-76b push the boundaries of our understanding of planetary science. They make us question what's possible in terms of planetary conditions and compositions. Every time we think we've seen the most extreme planet possible, the universe throws us another curveball. Now, I know what some of you might be thinking. This all sounds great, but how do we know all this? It's not like we can send a probe there. And you're right, we can't. At least not with our current technology. But the beauty of modern astronomy is that we can learn an incredible amount just by analysing the light from distant planets. We use a technique called spectroscopy, which is basically splitting light into its component colours. Different elements and compounds absorb and emit light at specific wavelengths, creating a kind of chemical fingerprint. By looking at the light that passes through WASP-76b's atmosphere as it transits its star, we can determine what that atmosphere is made of. It's kind of like being a cosmic detective, piecing together clues from across light years of space. And let me tell you, as someone who grew up reading mystery novels, There's nothing quite as thrilling as unraveling the secrets of a planet hundreds of light years away. So what's next for WASP-76b? Well, with the launch of more powerful telescopes like the James Webb Space Telescope, we'll be able to study this hellish world in even greater detail. We might discover new elements in its atmosphere, get a better understanding of its weather patterns, or even find other equally extreme planets out there. In conclusion, WASP-76b is a world of extremes. It's a place where the clouds are made of gemstones, where iron falls as rain, and where the winds carry vaporized metals at supersonic speeds. It's a planet that stretches our imagination and challenges our understanding of what's possible in the universe. You know, thinking about WASP-76b always reminds me of a quote from the famous astronomer Carl Sagan. Somewhere, something incredible is waiting to be known. WASP-76b is proof that the universe is stranger and more wonderful than we could ever imagine. So the next time you're caught in a rainstorm without an umbrella, just remember, at least it's not raining molten iron. And if you ever feel like your day is too hot or too cold, just think of WASP-76b, where extreme weather takes on a whole new meaning. Thank you for joining me on this cosmic journey to the most horrifying exoplanet ever discovered. If you're as fascinated by these extreme worlds as I am, I encourage you to keep exploring. Read about other exoplanets, follow the latest space missions, or even consider studying astronomy. Who knows? Maybe you'll be the one to discover the next WASP-76b. Until next time, keep looking up. The universe is full of wonders, and we've only just begun to scratch the surface. Clear skies, everyone.